Bismillahirrahmanirrahim. Hi guys, how are you doing? Let's complete chapter 6, energy and work. Today we will speak about the power, al-qudra. The power is a measure of how quickly work is done, work is done. So, it is a relation between work and time. The faster work is done, the greater the power. The faster work is done, the greater the power. Formally, power is the amount of work done in a given amount of time. If work W is done in time T, then the power delivered is defined as follows. Power equal work over time, so W over T. You know well that the work is measured in joule and the time is measured in seconds, so joule over second, we call it watt. Let's see the unit in another way. You know well that power equal work over time and work equal force times distance over time, right? So P equal F D over time. But hold on, the force equal MA, right? Times D, the distance over time. So the unit of mass is kilogram. The unit of acceleration is meter per second square times the unit of distance meter over second. So the unit of power equals kilogram meter square over second power 3. That what we call it watt. So watt equal kilogram meter square second over second power 3 or kilogram meter square second power negative 3. It is the same as watt. To be powerful, an engine must produce a substantial amount of work in a relatively short time. So to be more powerful, you must do the amount of work in short time. Similarly, you produce more power when running up a flight of stairs than when walking up, right? So the one that walks has less powerful than the one that runs. The unit of power is watt. The watt, named after Scotch engineer James Watt, is defined as 1 joule per second. Thus, the watt equal joule per second. Doing work equal joule in a short time, a second. A typical compact fluorescent light bulb, that you call it a neon bulb, has a power of 23 watt. So it consumes 23 joule in a second. Another familiar unit of power is the horsepower, HP, abbreviation HB. The horsepower is defined as follows. 1 horsepower equals 746 watt. So the horsepower equals 746 joule per second. So 10 horsepower means 7,460 watt, and so on. A human power output is limited about 1 horsepower. Usually walk, مشي على مهل, a flight of stairs require about 130 watt. 130, it is approximately 1 over 6 horsepower. A person running up the same stairs might be able to produce a little over power, approximately half power, 350 watt or more. This schedule, for example, of power appears in the table below. This is not for memorizing, guys. So, power output is an important factor in the performance of a car. The greater the power, the less the time it takes for a car to accelerate. To reach 100 kilometers per hour, you have many types of car. The one that is expensive in race, that reach high speed in short amount of time. Power depends on a force and speed. Power depends on a force and speed because power equal W over T equal F D over T. And this D over T, that what we call it V, speed. So the power depends on the force and speed. Distance over time equal velocity or speed. As a car travels in a distance d, the work done by the engine equal Fd, and the power it delivers is P equal W over T, Fd over T, D over T, what we call it speed. So therefore, power is equal to force times speed. That's the end of chapter 6. Let's solve some problems about this chapter in next video. God bless all of you guys.